what PureScript has got, it's got a type called a number type, which is really like, it's also a floating point. So I don't know, maybe I must use, so I'm not sure. I'm actually not
That
even
could
sure what the
work.
right approach is. But it could be a floating point. I don't know. Oh, someone press record. Thank you. Let me share my screen.
I think if it's because it goes to JavaScript, it would be 32-bit as well. There is a,
Yeah.
I think it's a spec at the moment. I don't know if it's been implemented to bring
Yeah.
64-bit numbers to JavaScript, being big
Yeah.
number.
Yeah, that makes sense. Yeah. Yeah. So PureScript has that same issue, 32-bit int, which is fine, but I just expect I would like an int64 for some bigger problems. But anyway, I'm sure there are probably some big number type implementations, big int type implementations, but they won't be like built-in types, right? Okay, cool. So hopefully you folks can see my screen. So I think last time, I'm just looking at like what we wrote here, but I think we just got to the point of just dealing with ADTs, algebraic data types, or they're also called tagged unions or discriminated unions, right? Which is this kind of type where it's like, hey, I've got, so in this language, we've got kind of 3 keywords for defining types. There could be more common ones, I suppose. So you've got type. So the type keyword effectively is just giving a name. It's like renaming a type. You know what I mean? So here on the right, I've created a type, which is a record type. So open the curly, like just a curly by itself is syntactic sugar for opening a record type. So this, that piece there, this is just quickly a summary, but this thing is equivalent to something like this: record, open round bracket, close bracket, something like that, right? I think these two are equivalent. So the compiler will like replace this curly bracket thing where it's expecting to see a type with that kind of syntax. So what the type keyword is doing is saying, oh, for this type record with all this stuff here, can you also give it the name person details? Do you know what I mean? It's like a way of giving like an alias to a type, right? But they're still, either way, they're interchangeable things. So that thing is equivalent to that thing, if that makes sense. So that's what the type keyword does. So you could even say like, like type my int equals int, something like that. And it's like, oh, okay, so I've created a new thing called myint, which is the same as an int. So you can almost see these as just like aliases, like renames, right? So that's what the type keyword does. New type we'll come to now, but then data is allowing you to create these discriminated unions. So as a quick reminder, the record syntax there is really like so we call that like an and type or a product type. I'd call it like an and type because it's like it's got an age and a name, right? This is a record. It can't have one or the other. There's no like or construct here. It's like both of these things together. So it's like a group of them, right? And that's often called a product type in Mathsy type languages. Um, Whereas when we use the keyword data, we are able to put this like kind of pipe thing, and we're kind of saying, oh, it's a union type. So that means it's kind of more like an or type. So it could be a local person or a foreign person, if that makes sense. And so it can't be both. And it's certainly only one of these things, right? So that's more of like an or construct. And this is pretty cool. This could be quite foreign feeling from a like this we're all happy with, right? This idea of like a record and giving it a name, that's fine. Like all languages, I think, have this concept of a product type. A lot of languages don't have great support for some types like this. So you could certainly do this in like an OO language, and you could kind of emulate it maybe through like maybe like through a base class. So I could have like a person as an abstract class, and then I've got a local person as like a concrete class and a foreign person as a concrete class. So you could totally do that. It's just quite a lot more boilerplate. Whereas here you can see, you read this very easy. It's like, oh, a person is either this or that. And when you're this, then you've got these things attached to you. So you kind of, so just from a naming perspective, you call this the type. So it's the type is called person. And these things on the left, that first word on each side is called the constructor. So this is a constructor. Local person is a constructor of type person. And if you like hover over it, it's actually brilliant. So it tells you local person is a function. So if we read what's on the right, it's like certainly a function that takes a person details and gives us a person, which is exactly right. So we're saying local person takes a person details and it will give us one of these types called person. Do you know what I mean? So it's a constructor. It's absolutely a constructor. So you could even think of it like an OO type of constructor. It builds this object. So you imagine that's the abstract class person. Call either local person or foreign person to construct a person. When you call local person, you give it these things on the right. So the right is like what parameters it takes in order to construct it. And of course, this can go like, n levels deep. So you could even if we had another, and of course you can have as many constructors as you like, but like say we have a dog constructor could itself also take like a record on the right as part of its so there you can see we're combining like a sum type with a product type, right? Does that kind of make sense? So data can wait, is data always have to be a I'm actually not sure. I can't remember. So let's go data test equals, can I make this a record? I don't know if I can. No. So I think like if it's going to be a sum type, it kind of has to have a constructor as its first. It has to have at least one constructor, if that makes sense. So if you wanted to, you can certainly have a discriminated union or an ADT which has only one constructor. That's totally fine, but you've still got to name that. You still have to give it a constructor. So it would be like I could do that equals test. So now I've got a type called test, and I call test to construct it. So this is very common, but also very confusing because it's like, well, that constructor has got the same name as the type, and like that is confusing, but it's very common. But you can see, like, I think if I hover over there, now you see even my like IntelliSense is confused because it thinks this test is the type test, and it actually isn't. That's the constructor. So if I rename that to make test or something, and I hover over that, you'll see, oh, make test is a constructor which will give me a thing of type test. Test is itself a type. Does that make sense? So you have to have at least one constructor for a data, if that makes sense. Any questions on that? On these things? We'll play with them a little bit more, but any like big glaring
I've got
holes
a
there?
question.
Yeah.
So I think in OO like language, if you have an abstract class and now you've got your concrete implementation, once you
Yeah.
initialize the constructor, it's always going to give you back the concrete type. You're never going to have an instance of the abstract class unless, of course, you make it explicit that that's what you're returning. So if I take the local person or maybe let's say the foreign person constructor, am I going to get a person that is able to access the properties of foreign person like years of residence, or am I going
Yes.
to get back a foreign person?
Yeah, I see what you're saying. Yeah. And maybe there is a subtle difference here between this and like OO class type of stuff. The difference is foreign person is not a type. It isn't a type. It doesn't exist as a new type. It is absolutely of type person. So foreign
Okay.
person type is person. So when I pass it around, I have to pass around person. But it's very easy through pattern matching to get back to the foreign person. So it'll be interesting when we so constructing stuff is through these constructors, but then destructing stuff. So later when a person gets passed to you and you want to go, oh, wait a minute, like I need to, like if this is a foreign person, I need his years of residence or something. You'll see that we'll use like a pattern matching approach to destructure it into
Yes.
like it's more like a concrete type, if that's what you want to call it. Yeah. So
Okay.
you'll see that these constructors are used not only to construct but also to deconstruct when you're handling them. Whereas in OO, so in OO, I mean, correct me if I'm wrong, but if this was an OO type thing where that's a base class and these are like concrete classes or whatever, I could still go like person P equals new foreign person, right? And that would do like that's doing like an upcast, right? So I would still have P as a thing of type person, right? Which I could pass to a function that takes persons, correct? And then in there, I would have to go, oh, is this a foreign person? And then I could downcast it back to the foreign person, right?
Yes,
I mean,
exactly.
I could do it this way, or I could say foreign person. I mean, both of these are valid in OO. It's like either I'm dealing with the base class type P, or I'm dealing with the foreign person type P. And of course, I could go, oh yeah, so I can upcast. So I can say person A equals, so say, sorry, that's the, like this is P1 and this is P2 or something, and then this is A1. I could take P2 and sort of cast it up to a, I don't think I need to upcast, right? I can always upcast, I think. I would have to downcast, right? Person A, I don't know, something like that, right? So I could take P1, which I know is a person, but so it is of type person, obviously, but I kind of know it's a foreign person as well. So I can downcast it, right? I think I can do that. Or maybe there's like cooler keywords like as or something. As foreign person, maybe.
Yes,
which is
and
like maybe a
depending on
safer cast or something like that. I don't know.
Yeah.
But kind of the problem is like quite often that's a bit of a dangerous. It's not to say it's dangerous. It is kind of dangerous, right? Because P1 is like, well, how do you know it's actually a foreign person? Like
Yes.
if I change that line of code up there, it's like, well, this line isn't, now what is it going to do, right? So it's like I kind of always have to go like if is instance or something of P1 dot is instance of, I don't know how this writes, but is instance probably of like a type thingy, I don't know. And then it's like, okay, now I'm checking that it is of the right type, and now I can downcast, and now I can like downcast, right? So like quite often the casting up and down can be a little bit dangerous, right? You're always doing, fundamentally that line is dangerous. It's less dangerous when you put it in the context of that, but it doesn't mean that this as a line is not dangerous. It is a dangerous line. Do you know what I mean?
Okay, got you. I think, foreign
yeah.
person is not a type. I think that's my mistake.
Yeah,
there.
it's not actually it's not a type. There is only the type person.
Person.
It's just person is like a union, like it can be of many. It can have a structure which is like an OR type structure inside it. I think this is a good way to think about it though, Terence. I think like to think of it as base classes and as a start is a good way to go. I don't think there's too many traps there, and you'll see when we pattern match them that it's actually very simple, and that the compiler does all that instance of type checking for you 100%. So there's absolutely no way of getting a person and somehow unpacking where you and you making the assumption that it's a dog, and when it's actually a foreign person. It's not possible. It's not possible to cast these things down to the wrong types, and you'll see, and I'll show you why. There's absolutely no null pointer potential or runtime exception that's possible with this, because pattern matching is so strong and checked by the compiler. Okay, so I thought like, although this is like a cool example, I thought like maybe let's like make a better example of these things, and then let's actually write some functions. So like I actually thought, I was trying to think this morning, like what's a good like ADT example, and I thought like maybe like food, like a menu, right? A menu of items. So like a restaurant menu, right? If we've got pizza and pasta, these things have got different types, and we can consider them to be food or whatever, but you could construct them differently. And like let's work with, rather than person and foreign person, it was like, well, that's like it works, but let's just build a new example of these things. So we're gonna so give me some ideas here, guys. So I'm gonna go data like food. Maybe that's not a great name, but let's start there. And it's like, okay, so we can have a pizza, right? Or we can have a pasta. Should we stick with Italian, or do we do fusion? Let's do sushi also, right? Okay, so we got 3 different types of food, right? We agree. Something like, I'm thinking of like a restaurant menu or something. So like allowing people to choose stuff from a menu, and maybe they can build up an order using these items. Does that kind of make sense? So we could then say, okay, well, pizza has got like many kinds of like toppings or whatever, right? So let's do that. So we'll say data toppings, and we can say like, what do you have on pizza? I don't know. What do we put on pizza? Everyone always loves banana on pizza, right?
Or some pineapple there for the wine lovers.
Salami, yeah, pineapple, exactly, pineapple. This very crappy pizza restaurant, this guys. So, okay, so we've got different toppings. So we can say, well, okay, so pizza, when you construct a pizza, you must provide it with like toppings, right? Probably a list of these things, maybe. I don't know. Yeah, talk.
Yeah, okay. So some important question just occurred to me. Like, it seems to me these are exclusive ORs, if you're going to think of this kind of...
Yes, they are exclusive. Yes, it's properly a union type. So it's like it's one or the other, not both.
Okay, could you? I mean, is it possible? Do you have like inclusive OR types, or is that going to cause problems with type checking, for example?
That's a good question. So exclusive, like, so where it's like an optional, but isn't that a problem technically? With like, it's maybe a combination of these two things. I can do that, right? Can't I?
I'm still thinking about it. So, like with the product type, mercy. Okay, like I deleted the example. Okay, there's one. Okay, a product type seems to have to have both.
Yes, but they could be maybe types, right? So it could be
I suppose you could have a product of toppings, you know, and then any one could be. Yeah, I suppose you could do that, right?
Yeah.
Or product of.
Well, let's see. Maybe we'll get into it actually. Let's try and construct an example where we confuse it. Because like a product or a proper OR type would be at least one of them must be set, right, for it to be.
Yeah.
But this is really exclusive OR. Yeah, I think you're right. I think so. When I look at data food, it's like it's one and only one of these. Can't be pizza and pasta, not sushi, right? It's like one and only one. So that is kind of exclusively. It's more an exclusive OR type of thing. Although there's like 3 options here, so I don't know. Let's get there, like how we may be able to model that. I think it's quite interesting. I think possibly it is possible. Okay, so toppings, that's fine. And then for like pasta, do we know different? Yeah, I suppose we do. So we can say, I suppose pasta has got like a combination of, actually, like even pizza has got like different bases, right? Base, I don't know. Yeah, oops, don't do that. Base is like, I don't know, normal base, and then you get like gluten-free base maybe. And it's like, okay, so pizzas have got a base and a topping. Let's just call it topping. And it's like, well, actually, pizzas have got like a list of toppings, haven't they? Because you could have more than one. I suppose you could have 0 or more toppings on a pizza. So probably like list of topping makes sense, right? So it's like when you construct a pizza, you must specify what base and you provide a list of toppings. Yeah, I think that makes sense. Pasta, what do we have? So pastas, I suppose we have sauces, a sauce, and it's like tomato. What other kinds of sauce do you get? Like a creamy or something? I don't know. It's making me hungry, guys. So when we order a pasta, we want to specify a particular sauce. There's also like the pasta itself, right? Pasta, like the actual wheaty part. So it's like penne and what's the other? What other? Spaghetti, like that. I think pasta. So now here's interesting. I don't know if that's going to work. Yeah, it is, because that constructor is not a type, so it gets ignored. It's like it's okay that that's called pasta and that's called pasta. I think it's okay, and it seems to be happy here, so that's fine. And it does say, yeah, pasta is a type. This pasta is actually a constructor. The IntelliSense is getting confused here. But this is quite common, is to go like, oh my God, why are the types and the constructors given the same names? It's very common. You'll see this a lot. And then sushi. Okay, and then, like I think we got it, right? Sushi, I suppose we can say data, I don't know, fish equals salmon and tuna, right? So when you order sushi, I mean, this is not the best sushi, but that you can choose a kind of fish, right? So it's like, check it out. Like with this pretty simple thingy, what we've managed to do here is we've been very specific about what food is, and we've also like what I think is quite interesting is we've eradicated something called like impossible types. There's no way of constructing like a sushi and then by mistake like setting field, you know, like it's not possible. So you'll see when we actually do it. So let's go like my order. Like what I want is I want pizza, and it must be normal, and then it must have a list. How do I create a list actually? I think like this, and I say I want banana on my pizza. Yeah, and so it's like, well, my order is a food, obviously. So it's like, there we go. Comfortable with that. So so this is what Tom wanted. Tom's order, and we can have like Vincent's order. What do you want, Vincent?
Let's have, I don't know, pasta, spaghetti. With
You have to give us a sauce before
creamy
the spaghetti.
sauce.
Creamy spaghetti. Oh, fantastic. Yeah, there we go. So it's like it's type check. It's not happy with that. That's fine. We'll give it that. Okay, perfect. So can we do something wacky like can we confuse it and we say actually we want a pizza with a tomato sauce and tuna? No, we can't, because it's like, oh wait, what's the issue here? It's saying could not match type sauce with type base. Like you gave me a sauce, but I'm looking for a base. Do you know what I mean? That kind of makes sense. So like, I mean, maybe it's worth saying like, how would we have done this naively if all that we had was product types, right? Which is very common. So like in a lot of solutions, we solve stuff using product types a lot. We may have gone like, I don't actually know how we may have done this, but like we might have said like, well, food is like, okay, it's some kind of record type thing, and it's like, I don't know how we do this. So we say like, is it a pizza? You know, Boolean. And if it's a pizza, then it's like, here's the pizza. You know what I mean? And then it's like, you know, toppings might be a list of things which is kind of alongside the pizza. It's not so much like built into it. I suppose we could have, if we'd done it properly with classes and stuff, I think we could have created more of this. But like here's what we've done is we've eradicated using this ADT, we've eradicated the ability to create crazy stuff. Like it's not possible to have a weird flag or like field floating around attached to our thing. And we know this, right? We've seen code a lot of the time, which is like, I don't know, where it's like we have in our food, we've got like toppings or whatever, and in this thing, we've got a list of things of toppings. But then it's also like, oh, attached to this thing is like, why is there a sauce? And then it's like, oh yeah, we must always set that to null because we know that this is a pizza, right? So sauce doesn't don't deal with sauce if we know that this thing is a pizza. You know what I mean? So like type pizza has toppings, and it's like, why is there field sauce here? It's like, oh no, that's only for pastas. Do you know what I mean? Like we know this. I'm not saying like we do this, but like we've seen code before which has got fields added which are generally null, and they're only looked at in certain situations of that structure. Do you know what I mean? Like maybe this is just me, I don't know, but I know I have written code like that a lot, where it's like, okay, yeah, I've got to add this new field, and it's only useful in one particular context of this object, right? Does that make sense?
Yeah.
Do you guys not write code like this?
An example that comes to mind for me is
Yeah.
in your users table, you'll typically have like an isAdmin flag. And like only if that's checked, then they're allowed to access certain things, for example. Or like look at other things on that user object.
Yeah. I think that's a good example. So it would be like, so let's explore it. So it's like a user has got a name or something, that's fine. And then isAdmin for sure, which is like false maybe. But then there might be like admin rights, you know, which is a list of rights he has. And it's like, so what we've done here is we've gone like, oh, this is a weird scenario, because look, this user Tom is not an admin, but then why does he carry around a field called admin rights? Like technically, like admins shouldn't have this, shouldn't have that field, but admins that are true should have this field. Do you know what I mean? Like blah, they've got blah rights. So so the interesting when you like is admin by itself is not problematic. It's the fact that when that has got a particular value that you're expecting some other field attached to it. So this is like saying, like when you're a pizza, you have bases. When you're a pasta, you have sauces. Do you know what I mean? And when you're a pasta, you certainly should not have bases. Like there should be no. So it's like it's linking. Does that make sense? Like these two things are linked. However, when it's false, then it's like whatever this thing. And so even if this says blah here, and it's like, what the hell does that mean? Why would he have blah if he's not an admin? So it's like, oh no, you must just ignore it. You know what I mean? Even if this is empty, it's like, does he have no admin rights? But here it's saying he isn't an admin. So why would he have no admin rights? It's like these things don't exist. Like in a world where you're not an admin, there should be no field called admin rights. In a world where you are an admin, there should be a field called admin rights. Do you know what I mean? And that's what, and I'm not saying like this is like you're forced into this, not at all, because you could have said like admin, admin could be a full-on new object or something, right? Which could contain that behavior of that linkage. But what's beautiful with some types is like very explicit. It's like here it is. It's like either, so it's like a data user equals either you're just a user and you have a name as a string, or you're an admin and you have a name with a bunch of rights. Do you know what I mean? So it's not possible that you can be a user with an admin's rights attached to you. Do you know what I mean? Like that's the capturing of that function right there, of that functionality. Yep, happy with that. I think we've got ADTs, guys. Like they're not too tricky. Let's just do something quickly where we want to unpack them. So more around like Terence's question of like, okay, so that's fine. However, when I place order or something, so I'm going to write a function which is going to take one of these orders and it's going to, I don't know, it's going to send it off to the printer or something, right, to print it. So what we do is we take a food, obviously, and maybe what makes sense here is actually I just want to like return a string, right? I think so. I'm just going to, so place order, you're going to give it a food and it's going to return you back the string of whatever it was that you placed. So here we can unpack it, right? Comfortable with that? So now we might write this function a few times. So the first way, I suppose, we could figure this out. So like maybe what we want is a string that looks like this, like food or pizza. Let's just print it like this. Regular. What kind of base did we have again? Oh, normal tomato. And this would be a list, right? Comma, banana. I don't know. I'm just going to return a string like that or something, right? Okay, so first of all, like when we look at food here, we're going to know that it's a food. It's of type food. We need to kind of unpack it into its thingy. So there's many ways we can do this. Here's maybe the sort of like the most naive way, which would be, okay, we've got to pattern match it. So we need to do a case of. So I think we talked about pattern matching earlier. So it's saying, okay, well, what type is food of? And now you can say, well, it's of type pizza. And then now we unpack these things as variables. So it's like we specify the constructor and we say base. Now it's lowercase because it's like we want that as like a value or a variable, right? And then here we want a list of things. It will be like toppings. So that would be our first match. Pasta would be with a sauce and a pasta, and we would have a sushi with a fish, right? Something like that. And so let's just do this immediately. We can just say pizza, pasta, fish. And there's our function. Okay, it doesn't do the unpacking of the in-betweeny stuff yet, but let's just test this out. So we can take, okay, we got Tom's order and Vincent's order, so we can just log this, right? So we can say log Vincent's order, and we can just append it to place order of Vincent's order, right? And then we probably need to bracket this thing potentially. We probably have to bracket this whole thing actually. Actually, I just do that, I think. Yeah. So log takes a string, right? So we're just building a string over there. Do I need these brackets? No. Yeah. Cool. So we can run that. Yeah. So Vincent's order was a pasta. So we're happy there. Like look at that, Terence. This was your. Here's now taking the base class and kind of figuring out what concrete class it is through a pattern match like that. Comfortable with that?
Okay, Terence disappeared.
Oh, sorry. Yeah.
Do you have to import cast? My cast is not working on this side.
No, this is case.
Case. Yeah, no, I mean case.
No, case is a built-in thing. It's part of the syntax, actually.
Yeah, I'm probably screwing something else up. Never mind.
What are you missing? Maybe the equals. Case food of. You need the of?
Yeah. No, that's it.
Is it working?
Let's not worry about it now.
Okay. No, there's no imports for that. This is like it's a built-in. It's a keyword. It's not even like an imported thing. I don't think so. No. So this is like one way of doing it. Another way, if we remember our cool pattern matching thing, is like, remember we could pattern match actually up here. So we could actually say, like, when we place an order, we can pattern match here. We can say when we get pizza-based toppings, that equals pizza, right? That's one way of doing it. And two other options are like, actually, I'm going to kill sushi because there's like too many freaking things to duplicate here. So we only have pizza and pasta at our restaurant. That's all we actually need, right? And this is like a sauce and a pasta. And so we could actually pattern match here. I'll make this time to be cool. So we can do our pattern matching as like these like function overloads. Remember we talked about that. It's like, oh, we can pattern match right here in the parameter. Like we didn't have to do the case food of piece and go and give this thing a name, like food and food. There's pretty redundant, and that whole line is redundant because all we're doing is we're matching those things. So just lift them up into the parameter as a match up there and just put down two functions, right? And that'll work. It'll work basically the same, right? Comfortable with that?
Yeah.
No?
Tom,
yes.
I have a question around, like, which one is better? Is it just a style thing, or is there a significant difference between the two?
No, there's no difference. It's what you feel like reads better, in my view.
Okay.
I prefer this because I do like it. Look how compact it is, and actually it's totally readable. Place order of a pizza with some bases and a toppings equals that. It's like, yeah, that's cool. But like if that feels foreign, because it does look a bit foreign, like that doesn't feel like most other languages, whereas that does, where it's like, oh, I've got a thing and then I kind of do an if kind of thing earlier. I think you probably start like this naively because you're in beginner mode and you think about like what does this function do. But over time, I think that's probably more common. You'll see this more commonly of like deconstruct stuff in parameters 100%. That's probably more common. And of course, remember we can deconstruct that as well. So remember, bases is also of bases have got normal and gluten free or whatever. So you can create like kind of all the variants here of base as well. So you could say where it's a pizza with a normal and a topping, it's like pizza normal and pizza gluten free. And now we can kill that one And we can say that, and now it's like, oh, cool. Like now we can, you know, that, and that's complete. Like if we had to leave out this one, the compiler would tell us, hey, you're missing the gluten-free option. Do you know what I mean? So you can't really mess it up too much. We did see with guards, you had to add a few extra. You had to add like a default case, which was annoying. But the compiler shouldn't let through. It won't allow you to leave out impossible scenarios. So it's like it's really hard to make this language throw a runtime exception where it's like, hey, you're not handling a particular case. You've left out one. Or it would be difficult to do it, I think. So like that's pretty cool, don't you think? And of course we can just keep deconstructing, right? Interestingly, toppings is like now a list, so we'd want kind of some kind of list syntax there. But an interesting so now that we've got this cool structure and we've got this kind of printing idea going on here, it's like so I wanted to move into something called type classes quickly, because so earlier we knew that, like, for example, say we had yeah, let's just do like a little let expression here, and we'll say in, and we say like x equals 55, right? And we wanted to print, I'll keep that guy. Let me just comment it out. So I want to log x here. What is this saying? Unexpected do. Oh, because I've got the do up there. Sorry. So this needs to be in do. We're going to get to what does do mean at some point. But if I just log x here, it says, okay, but hang on. Like int is not a string, and log definitely needs a string, right? So there's no kind of automatic like coercing of types or like automatic casting. There's no automatic toString being done at all. Like that, you can't really do that. But a common way of turning things into two strings, right, would be like, so in C# or any other language, you may expect to see like a toString type of function on this thing, right? In PureScript and Haskell, there is a function called show. So show is a common function for stuff. So this is, and if you look at it, it's like, okay, it's a bit confusing. So that upside down A means for all. Remember we saw that for all thing. And even I'm not 100% certain what that's all about, but you just put it there. Show A, and that's the type class. So it's saying, so if you ignore the show A and the fatter arrow, if you look at just the thinner arrow, it's saying an A to a string. So, and we know that it's the lowercase a means for any type. So of any type to a string, right? Comfortable with that. So this is saying, oh, okay, so you gave me an int. Int is an any type. It's certainly a type. So I'm going to call a function which is going to take an int to a string. So if you, and you say, okay, but that's fine. So of any type to a string, what about a weird type like our Vincent's order, right? So can we go log show of Vincent's order? Because it can take an any type, right, of type A. And it says here, okay, no type class instance was found for show of food. So now let's try and understand what, like, how does this work? So if I hover over, I see, can I copy this part? Yeah. So I can see that show has a type that looks like this. So it says, yes, from any type to a string. But there's this fat arrow thing here. Let me turn this into an actual fat arrow and this into an actual thingy. This fat arrow means it's specifying a kind of a constraint on A. So it's saying as long as A is of type, has the type class of show, or has an instance of the type class show attached to it. If that kind of makes sense. So effectively, when you read this, you can say, yes, from any type to a string, as long as that any type has an instance of the show type class attached to it. Okay, so that's just from a reading perspective. And we can see here that this one doesn't have it. So how does show of X work? Let's go actually to the show method and we'll see, yes, okay, so it's a class. So this is a type class. So show is a type class of any, that instance has a show method which takes that type to a string. And if we just scroll down a little bit, we can start to see how this plays out. So it's like, oh, here's show Boolean, which is implements. So this is all new syntax. Don't worry too much about the syntax. We'll write some of these. But when you read it, you can say, oh, there's an instance called show Boolean, which is an implementation of the type class show for the type Boolean. So this is saying, oh, show where Boolean is the A. Does that make sense? And so here's the method, show where it's true, make, set like return the string for true, and show where it's false, return the string for false. That kind of makes sense. So here's how Boolean gets done. So earlier we had show int. We were calling, remember, we were saying show of 5 or something. It would execute this instance of the show type class, or an instance of this type class. So it would execute this show int impl, and I think this actually ends in a JavaScript rabbit hole. But let's implement our own one, right? So let's fix this thing where we can say, where we want to show Vincent's order. Let's write our own implementation of show. So what this is saying effectively is that there's a method, a global method called show, and it can show any type. As long as you tell show how to show that type, you can call show on it. Does that make sense? As long as it's constrained by that type. So let's write our own one. So we'll say instance show food, and you just kind of give it a name. That name is actually pretty meaningless. And it is an implementation of show, but for food. And I think we go where. And we say show the food equals. And let's be specific, because we'll say show takes a food to a string. And now we can actually do our lacquer thingy here. I'm just going to paste those options in here and make this thing better and call this show, not with the little primes. And if I press save, we've now implemented the show type class for food. And look, our compile error goes away. So now show knows how to show Vincent's order. So I think if I run that, we see 55 and pasta. Does that make sense? This could be mind-boggling, because this is a little bit different to a lot of other languages out there. Here it's like, oh, I'm calling this global function called show. This is not my show function. But it's like I'm implementing an interface almost for my data type for that global function called show. And what I'm telling the compiler is like, oh yeah, when you want to do that, when you're searching for how to show a food, here's where you must look. Find this instance of it.
So Tom, would this be a way to think of this? Would be like overriding the like in OOP languages, we all inherit from object, and object has by default toString.
Yeah,
so show could be the toString, and we've just overwritten that per type as a nice way probably to think about it. Because you have to be explicit, like toString, be explicit as well.
Yeah. But it's like
there's just no default implementation which object gives you, which is a horrible implementation by default, but yes.
Yes, and also without this, so when I don't have this, this is now a compile error. And look, I haven't touched food. It's not like I implemented it in the food data type. I've implemented it as like this. I've actually inverted the dependency of toString here, if you think about it. So like in the OO world, if we use OO as an example, I think it's a good example, is toString is kind of inside the data type. So like the data type has a toString method inside it, right? Here what we've done is we've said actually it's the opposite way around. We said there's a toString method, and the toString method knows about the type and provides an implementation for it. So the arrow goes the other way around. Rather than food knowing about show food knows about food. So it's like the dependency of toString is like inverted, which is actually pretty cool, because I could even do it for like, I can even create my own instances of stuff that's already out there. So it's like, I think, let's try this. So like my show int, where I could say, oh yeah, so when I show ints, I want to do them like this. Show int equals, like always show ints as 555s. This could say like, ooh, we've orphaned it by declaring the instance in data.show or defining the instance on a new type wrapper. Okay, so there's ways to fiddle with this, but effectively I can kind of overwrite what the show int function, that one there, show, which takes an int. I can kind of provide my own instance of it, which might be like slightly different, might be subtly different. But the compiler is saying like, wait a minute, you've already imported show because I've imported it from, it's kind of in the prelude probably that we've got show down here. Show is there, and yeah, because we're importing that, show comes with its own implementation of show int. So the compiler is saying it's a little bit confusing, but technically I can do this somehow. Do you know what I mean? It's like I didn't have to necessarily go and modify it inside that object. You know what I mean? So it's like I've inverted the dependency. That's kind of how I think about it. The other interesting thing is like, so this can of course flow down because we could be showing food, but we could also show bases, right? So we could go, oh yeah, so like we also want a show base, which is a show of base, where, because remember, food has got a pizza, but it also has a base. So we want to like break up, like how do we print a base? This would take a base to a string, and show would be the base. So either we have like show of normal equals normal, or show of gluten-free is gluten-free, something like that. Show of, oh, sorry, equals, that's not a matchy thing. Yeah, okay, so now we've got an implementation of show for bases. So now we maybe don't need to match up there because we can now call that show here. So we can say, oh, it's a pizza, but with a show of base, kind of like that. So that show is now of type base, which will execute that instance of show base. So if we were actually printing something that was a pizza, let's print Tom's order, we might see the pizza base being printed as well, kind of like that, right? So it's kind of providing a two-string method for stuff through this show type class. So we're implementing the type class because show, the function here, can print any type as long as that type provides a type class, an instance of the type class show. Show can be called on it. Comfortable with that? Sort of. Yeah. So show is a good example, but there's a couple of examples actually. There's other stuff like, what if I wanted to go like, if I wanted to compare two orders, right? Same order, and I go, is Vincent's order equal to Tom's order? Do you know what I mean? Oops. Show X is now dead. And this thing goes, yeah, but hang on. You can't just compare two things like that. I don't know how to compare. And actually, it's like when you look at it, it goes, oh, but you haven't implemented the type class for EQ or EQ. You haven't implemented the EQ type class for food. So like the compiler says, I can't compare these things until you do that. And then you go, oh, cool. So I can actually compare them for equals by going instance EQ food is of type EQ of food, where, so now I'm implementing the equality function for things of type food, and I can't remember what it's called. I think it's just called EQ. If I go and look at, if I go and look at what EQ looks like, you can see, EQ just needs a function that looks like this. And look, it's a bit different to the show one because it's of type something and a something, giving me a bool. Those two somethings in my instance are foods, definitely. And I go EQ food 1 and food 2 equals, and now I can implement my like, are these two things equal? Do you know what I mean? By comparing fields inside them, or however the hell I want to do it. My dumb one is going to go, what's it going to do? It's just going to go, let's just say, if they're both pizzas, we'll assume they're equal. So if it's a pizza and a pizza, then it's true. Otherwise, anything else, it is false. Doesn't like that. Oh yes, because it wants me to unwrap the pizza with any toppings and any base. So any two pizzas, no matter what they have on them, they are equal. Anything else, they are not equal. So that's obviously not a good implementation, right? You do see that's a bad thing. And now look, my compiler error has gone away here. So it's saying, yeah, same order is cool. So now we can compare these two things. And that's pretty cool, right? So it's like I've So that's what. So when I say it's like the dependency is inverted, it's like equalities, even as a thing, is like, oh, I don't have to do that inside my data type. I can do that kind of outside. I can keep it separate.
So what I'm liking from what you're showing at this point is the one that's, I want to say minor issues with like in C# is that you get lulled into a false sense of, if you don't understand, say, reference types versus value types, you get into that false sense of, oh, no, I can just compare these two objects. And it's like, but why is it giving me false? And then you get down another rabbit hole of, okay, I'll do it myself versus implementing an interface that gives you the equality comparer and everything. This is making you explicitly do it.
Yes.
So by default, it's like, no, we're not going to give you a default implementation. You need to tell us from the ground up.
Yes.
This is how you want it done. Where, like, I want to say, like in C# because that's my primary. Like,
yes.
Yes,
I think this is actually interesting.
And you need to tell us otherwise.
Yeah, because how does C# do this? So if I go var a equals new person, and I like whatever, and I go var b equals new person, can I go a equals b? That will be false, right? Because they're different references, right? They point to different objects. So even though this may be Tom and this one may be Tom, this would still be false, right?
Yeah, that would still be false. You would have to implement the equals operator, or you would have to implement an interface, which is the iEquality interface, which gives you an override that's a more non-generic version of the equals operator that the framework understands and knows how to use.
Okay. So, 100%. So that iEquality thing is very much like a type class, if that makes sense. That's kind of how, certainly in PureScript Haskell, it's more that type. It's like you provide an instance of, an implementation instance of how equality works. You don't have to do it inside the data type. Like that doesn't make sense to have it in the data type. So it's kind of outside. So it's more like the iEquality. But so I think I think what you're trying to say is C# by default. This would be, the compiler would be happy with this. It would say, 100%, let's go. But it's going to be false, and that might be surprising to some people. Some people might say, but come on, guys, these are the same. Whereas if I go var c equals a, here I'm copying the reference, and now actually a does equal c, right?
Yes.
So that one is a yes, and this one is a no. Equals no, equals yes, because they're the same reference. So by default, equals, I think, compares references. Are they the same object?
Yeah, it's double checks that they're the same pointer in memory, because that's the default implementation from the inherited object class, like 9 levels, whatever down.
Yes, I got you. Yeah, absolutely. So in PureScript Haskell, it doesn't make any assumption. It's actually up to you. So your eq instance implementation must specify what it wants to do. If they're identical, so there's no real concept of a reference, I think, in these languages. It's not like it's, Vincent's order, there's no reference type in this thing. The type is the type. There's no reference or value type. There's no difference. Everything is a value type. I would make the assumption everything is a value type. Under the hood, of course, there's pointers to references. Of course, it runs on a machine that uses the heap. But in this language, there's no confusion about reference and value types. There's no such thing. It's just like you have a value and another value, and those two things are values. You can compare them as values. There's no such thing as saying, oh, but they both point to the same thing. It's like there's no such concept. It's like they're the same value. Do you know what I mean? Like everything's a value type. Happy with that?
Yeah. That makes sense
So,
to me from what we've gone through.
So like we've dabbled a little bit now in type classes, and there are lots of type classes. So let's see what other type classes there are actually. So wherever you see the word class, that is a type class. So this is saying there is a thing you can implement which will give you some function. So like some of these are a bit confusing, like bind and stuff, and monad and category. Let's see if we can find one that's interesting. So without diving into like hectic maths. Okay, here we go. So like ordinal is interesting. So odd is interesting. Ignore the ordering underneath. I actually don't know what the difference is there, but like odd, the concept of odd is that stuff can be ordered. You know what I mean? Like things have got an ordinal, so it has like an index. So you can see like, is this thing bigger than this thing? So if there's two types in the world, so in fact we could even in our pizza thing, we could say pizzas can be ordered. If that made sense in our world, because we could rank pizzas and we could say actually like normal bases are less than gluten-free bases. Maybe this makes sense in our world. It doesn't make sense for food. Like you wouldn't order food. There's no natural reason why you do this, but you totally could. You could say like food is something which has a natural order to it. It could even be like you could create classes of users, right? And you could say, like maybe you wanted to write code, you know, where we had our admin thingy. We could say, you know what did we have? We had like data user. Yeah, user makes sense. And either you are a regular user or you were an admin user, right? Or you were like a Uber super user. So maybe it's like, oh, here's our, like actually if you think about this type, there is like a natural ordering in it. Well, you could consider that there's a natural ordering. You say, well, regular users are less than admin users, which are less than super users, right? You could say, actually, that's quite interesting. You might want to have code like you might have a function called like isAdmin, and that isAdmin takes a user, and maybe your implementation is just like, well, user less than or equal to admin user. You know, you wanted to do that. So no matter what you passed in here, as long as it was a super user or an admin user, this would return true. I'm not saying this is exactly right, but you wanted this kind of syntax where you could say, like you want to start using comparison operators against your object so that you can say, yeah, user less than admin, then we're good, then you're not an admin or you are an admin or whatever. Then it would just be a matter of saying, well, so if you look at like what operator we're using there, it's like less than or equals, right? So it's like, oh, it's that operator there, part of the data.ord. So how does that work? If we go into that little less than or equal to operator, sorry, it will be that one, see that it's like, okay, so it will work for all types. So hey, you got that cool ord for all types, as long as they implement the type class ord. So it's like, oh, cool. So we can have this work, and it's got to implement. It looks like if we look at the ord type class, oh, it's just got a method called compare. So given one and the other one, return an ordering. And ordering is either less than, greater than, or equal to, right? So it's just like it's a little bit better than the EQ, than the equality is one, because it actually does EQ as well. It does equal to. So then it's like, oh, we could implement that because we could just say, cool, instance, what is this? Compare user is of type ord of type user where, and then we go compare. So we implement the compare method. Compare takes a user, and it returns an ordering, which we saw. Compare user 1, sorry, user 2 equals, and then we go, and now it's like, now you can implement your compare, which would be like regular user and admin user. That would be, the ordering would be, so this would be on the left. So if you imagine that the less than, so when we go compare, I think it's this one versus that one. So it would be, you would go less than, right? Equals LT. Compare of, you know what I mean? And now you would put in all the scenarios as to what this thing returns. Admin user, you know what I mean? All the combinations, or you could like, you know, write out your code nicely and just return the kind of type. And now suddenly you have the ability to do this less than or equal type of thing for your users. Does that kind of make sense? We're out of time. Any last questions? How's it, Kartik?
How's it, Tom?
Are you following this stuff, hey?
Yes, and I'm super confused at some stage because I'm joining in the middle, but yeah. I'm actually trying to see how much of it ties back to TypeScript, but not a lot.
Yeah, potentially. I think a lot of languages are quite inspired by these kinds of things. So like pattern matching and destructuring. And some types I don't see a lot of, but yeah, absolutely. I mean, this is a pure functional language, so it's going to be very, very foreign. But it's not that bad once you start like wrapping off the layers and you understand type classes. And actually, now that we understand type classes, we can start to understand almost everything in the language. There's not like much more to it. So when we like hover our mouse over things, you can now start, you do need to get to the point where you kind of understand everything in that line.
Yes.
You know, in the last few lessons, well, not lessons, it was like talks or whatever, we've understood that last part of like, oh, a thing to a thing. Now we've kind of understood like, what is this show thing in front? And it's like, oh, okay, so these are type classes. So as long as that type class, there is a type class for this type A of type show. We still need to understand this, and actually I need to understand this. I ignore this right now because this funny stuff.
But wasn't it like for any A, that type class?
For all A, it's type. But it's like that somehow interacts with the type classes, and it's not clear to me where that comes in. But like we're slowly unwrapping like how to decode what that means. And once you understand that, I think you kind of understand most of the language, to be honest. Are you happy, Matt? Bhavesh?
Yeah, I was a bit lost when I came in and saw the word show, but I think I caught up, so that's good.
Okay. Type classes. Did you get any of the type class stuff?
Some of it, but I'll watch the recording.
And then let me know. Yeah. Because this stuff is quite key. Like you should go through it.
No, definitely.
All right, cool. Cheers, dudes.
Also, what I learned today is that you have no idea on how to pick toppings or pastas or like everyday food items escape.
Quite right. So the problem domain is still the problem domain. Yeah. It's like, how would you model these things? I don't know. Like modeling is still hard. Yeah. Exactly. All right, cool, guys. Have a great day.
Thanks,
awesome.
Tom.
Thanks, Tom.
Later. Ciao.
Cheers, guys.